Yes, in this video, this is going to be the first video where we cover isometric drawings. And before we continue, let's first look at an overview. Let's really see what isometric drawings really mean. So before we get to isometric drawings, we have to first cover isometric projections. This is nothing but a more pictorial view of an object. So previously we looked at how to represent an object on a two-dimensional space, that is a paper on a paper, and we are looking at orthographic projections. So we represented an object using three views, that is the front elevation, the plan, and any one of the end elevation, either taken from the right or from the left. So those are the three views, three elevations, and that is known as orthographic projections. Now there's a more pictorial representation of an object, and that is isometric. It's part of axonometric. And one of those pictorial views is isometric. Of course, there are others like oblique, but we are only covering isometric projections. So the only difference with that is the axis of the drawing. So you suppose a drawing is enclosed, is perfectly fitted in a cuboid, actually in a cube, sorry, not a cuboid. It doesn't matter what drawing, but take the biggest length of that drawing and make a cube equal to that length, or having a side of that length, of the biggest length of the object. So place that object in that cube, and then if you are to rotate the cube in such a way that one of the edges appears as vertical and the others are 30 degrees to the horizontal, okay, then whichever view you are looking at is what we call an isometric projection, where you are able to see three faces of the cube, and in so doing you are able to see more like three elevations of an object, okay, of the said object we looked at in assuming orthographic. So with isometric you are able to see all three at the same time, so meaning you can see that plan, the supposed front elevation and an end elevation at the same time. So the key feature here is that one of the axes has to be vertical and the others will be 30 degrees to the certain imaginary horizontal line. So that is what we keep in mind. Okay. So the difference between isometric projections and isometric drawings is that with isometric projections we are not actually using the true length of the object. The length that is visible is only 80%, so about 82% of the true length of an object. So that meaning all the true length of the object have to be scaled down in order to produce an isometric drawing. So imagine if this were a perfect cube, then say it's a cube of 20 millimeters, side 20 millimeters, then the only true length that is visible in this representation is this diagonal distance from this corner to this corner, which is not the same as the distance from here to here. Okay, so meaning the rest are not true length. Okay, so that would make it an isometric projection. Okay, but since this is complicated, each time you have to produce this you need an isometric scale beside it to scale down the true length of the object. That is, if you have to copy the object from orthographic projection to isometric projection, so that would be a lot of work. So we take a shortcut, and this is by drawing isometric drawings, and these are also known as conventional isometric projections. And for the isometric projection, like the name suggests, sometimes it's called the true isometric projection. So what we are looking at are isometric drawings. The only difference here is that we are actually using the true length. We are not scaling down the length, so to make the work easier we are using the true length, but we are keeping all the other factors the same. We should have one vertical axis, and then the other ones are 30 degrees to the horizontal. So that is what we are going to do. Okay, so yeah, I'll head down to classroom exercises. Or maybe the other thing before I continue is that there's an example here where you would be required to draw a hexagonal prism, in which case you cannot take the true side of this prism and represent it here. Okay, so in this case you'd have to assume the prism is enclosed in a cuboid. Actually, generally we assume all objects are enclosed in either a cube or a cuboid, and what we are actually doing is we are taking the distances that are parallel to the isometric axis. Okay, these being the axes. So if we are to draw isometric drawings, we are mostly taking distances that are parallel to either this axis, or this axis. All the other distances that are not parallel to these axes, we cannot take them as true length of the object. So in so doing, what we have to do is to project all distances to a certain cuboid, and then, because a cuboid is the simplest object we can represent in an isometric drawing, because we would actually take the true length, true width, and true height to make that cuboid. So in so doing, we'll be projecting all these distances to that cuboid, to the sides of the cuboid, and then mark off those distances in an isometric drawing. Okay, yeah, that is the simplest explanation I can give you. So let's look at some classroom exercises, and the first one is this one. We are required to draw full size and isometric projection of the component shown in the following figure, looking in the direction of the arrow A. Okay, I forgot to change that. It should have read isometric drawing, not projection, because isometric projection would require us to use an isometric scale, but we are not going to do that. We are going to assume true length for any length that is parallel to the isometric axis, and like I said, the axes are at 120 degrees to each other, and one of them has to be vertical. You must have one vertical axis, and the other two are at 30 degrees to the horizontal. Okay, so the foremost corner specified in any drawing exercise is the one that sits at the point where the axes meet. So let's look at this one. Okay. For some reason my mouse tracking is very bad. But alright. So we are going to look at this one, and it's well, I don't know what it is. Some kind of block or bracket. So yeah, let's see what this is, what this gives us. And it's stated hidden details are not should be shown. So we have to put corner A in the components shown in the following figure, looking in the direction of the arrow A. So meaning arrow A should be seated somewhere here. Okay, because we'll be looking directly at that point. Right, so yeah, let's go over to AutoCAD. And so just to be sure, let's go over to AutoCAD, and you should be using templates. I'm using an STHE template which is already laid out and all that. There's a either third or fourth video about making templates, so just check this playlist, you see it. And in your template you should have certain layers, like I have like center line, dimension, hidden, then outline and viewport. You should have so many layers. Right, so before we get started, the first thing you need to do is to make sure there's a certain symbol that usually appears here that you can just toggle through, switch between 2D modeling and isometric drafting. Okay, so just make sure this is ticked, isometric drafting. Once you tick it, you should be able to see that symbol over there. If you untick it, it disappears. Once you tick it, okay, it should appear like that, and then make sure it's activated. It should be activated like that. And what we are going to do is, we can always switch the planes, because this is ISO plane left, and we can switch to the top. You can simply press F5, switch to the top plane and switch to the right plane. So I'm going to show you when you need to do this, especially when you're doing curved edges or curved surfaces. That's usually when you need to switch the planes, when you're drawing certain elliptical shapes. But for now, let's just start with the left, and we are going to first draw those axes. Click the line tool, and so now normally your line will be tracking. Okay, I need to so now your line will be tracking in this direction, 330 degrees. So that is okay. Well, it really depends on your point of your starting point. Okay, so 330 degrees, that's like we only left with 30 degrees to make 360. Okay, so what I'm really doing is I'll do that and then track 30 degrees upwards in this direction. I'm looking for 30 degrees, and then one which is vertical, that is this direction. Okay, so now I have those three axes, right? And what we want to do is to first construct the cuboid. Okay, so this is more like we are using the box method. Okay, there's an offset method and this is a box method. We start off with a box and then cut out the unwanted parts. So that's exactly what I'm doing here. So I'll take the maximum elevation wise, using the front elevation. We need this distance to be the length of whatever cuboid that is, and the distance, which is 32 plus 12.5 plus 66, is going to be my height, and then my width should be the distance, which is this is 25, 12.5 and 25. If I add them together, it should give me my width distance. So that's what I'm going to do. So first 50 plus 12.5. Okay, so or maybe let me just start with the height since I already have this point. Let me start at the top coming downwards. So my height is 66, 12.5 and 32. So I'll get the line tool and compute. It's more like adding that. We first add it because I'm not very sure of the total. 66 plus 12.5 plus 35, is it? Not very sure. 32. 66, 12.5 and 32. So 32. And yeah, that is 110.5. So that is my height. So what I'll do is to get a starting point at 110.5 along that line. So when I press enter, it's that far down. Yeah, so unfortunately I did not zoom in very well, so I need to undo this and try to, okay, let me try to move this some other place away from my ICS. Move it somewhere here. Okay, so first let me lengthen this as high as I can. Same with this, and I'll do the same thing with this. So along that point, from that end point, I need to make 110.5. So I'm actually going in this 30-degree direction. To about that point, I'm not sure where exactly. And I'll do the same thing towards the left, and this should be at 150 degrees because the balance would be 30 degrees with the horizontal, and that is a distance of 25, 12.5 and 25. So what I'll do, I'll say 25, 12.5 in the same direction, and then 25. So those are 3 points that I've created. Now I'll go vertically upwards and get that end point. So I'll still continue in this direction, 30 degrees to, I forgot that, take that distance. It should be 50 plus 12.5. So let me make that distance right away. I'll make 50 and then 12.5. I'm only doing that because the angle is still 30, so I don't need to stop and then continue and then stop. I'm just doing it at once because I think by now you should know how to do that. So you can see what I'm doing with this. So I'm going to stop at that point. So now we have that box thing of ours, and we need to kind of make divisions. So what I'm going to do is to I'll get a starting point of as this is 25, 12.5 and 25. So from here to here, I'm going to draw a line that goes upwards 32 millimeters. Okay, and then okay, yeah, upward 32 millimeters. That should do it. Then we will continue from there. You can just go step by step. So get your line tool and look for that endpoint, because the next one is 12.5 and then 25. Okay, so this one we go upwards 32, and I should go along 330 there, along 30 degrees. Okay, almost there, but not quite, because we have this kind of left facing L, so this point is what I was making. It doesn't have to touch here, it's somewhere there, but I just extended it beyond, which is here, beyond. So I'm going to do the same thing this side, and I'll track that point. I should be able to track in that direction. Okay, let me first see what I need to activate in order to track. Yeah, okay, so I want to track this point, and it should be, instead of typing the 32 again, which is this height, I should be able to just track that point, but in that same direction as I would if it were horizontal and vertical. So what I'm going to do, there's a setting here, polar tracking, click that arrow, and yeah, so there's this object snap tracking settings is set to track orthogonally only. So I want to track using all polar angle settings. Okay, this is a very dangerous thing to do if you are not doing isometric drafting. So make sure you always switch back to track orthogonal only, otherwise you might end up with making too many mistakes. Okay, so okay, now I'm going to track that point using an angle of 150. Okay, so in that direction, and I should be able to continue in that direction and get that end point. Okay, so I'm going to do the same thing here. I'll track that point, the end point, in that direction at an angle of 30 degrees. It should say polar, the angle is 30 degrees, then end point, the angle is 270. Okay, so the angle I'm tracking from the end point is at 270, and the one in that original direction of it's 30 degrees. Okay, so just mark that point, and we could just come back here. We'll cut off that part later on because it's not necessary. Okay, we are not required to do hidden details. So from here upwards it should be 12.5. So I'll draw a line starting from here going vertically upwards, 12.5, and at this angle of 330 I'll click there, and somewhere along there it should go as far as 50. Okay, as far as 50 millimeters. So somewhere along that we have 50, so it's exactly 50, but you have to be sure, so just type it, and then we continue upwards, vertically upwards. So click there, continue, and yeah, it's an end point actually there. Then vertically downwards, make sure you get those angles right, otherwise it's not going to work. Okay, yes, so I know this line coincides with that point, but make sure you don't get confused, so let me just get rid of it. Okay, and the line I actually need should be from here to, okay, now something went wrong. Yeah, I can see it's off, this angle is off, so okay, I need to figure out, let me first verify the distances. That is 50. Oh yeah, that's because I'm using the one below. It should be the one coming from here. Yeah, that's, it was me who did a mistake, so it should be there and then here. Okay, so that we don't need the one below because we are not interested in hidden details. Okay, so as you can see, our drawing is almost coming out, and you can get rid of some lines if you want. Right, and yeah, what else? So we need to draw the line from here to there, and then it goes up. Okay, yeah, so this is our end view as seen from this direction. This is what we should be able to see. So I'm going to first draw that line from there along 30 degrees. It's a distance of I'm forgetting, is 50 plus 12.5, which is 72.5. So 72.5, and then we go vertically upwards. So vertically upward, we should stop about there because we are not interested in the hidden details, and that is as much as we see on that point. So now it's time to draw our circle. Maybe before I continue, let me trim off what I don't need. Okay, so we can simply delete the rest, and these two. Alright, so this is our object so far. So now we need to draw the circular hole. Yeah, now that is the tricky part. So it has a diameter of 40. Yeah, so what we are going to do, just like before, we start off with a box and then insert the circle in that box. So the box should have a size, the diameter of that circle, because the circle is supposed to fit directly, and then that box is also located in the center of this, I suppose. Yeah, center of this. So I'll look for I'll look for midpoint and midpoint to locate that center. Actually, I don't need it. I don't need the box. Yeah, there's a trick to that. Okay, so there's a nice trick to this that I'm going to use. Actually, we don't need to do a box method. There's already a tool for that. So yeah, so go over to, remember when we used to do elliptical shapes, so go over to, don't choose the first one, so go to the second one that says axis and click it. Maybe before I go ahead, I need to, okay, my command window is not visible, so press Ctrl 9. And now my command window is over here. So what I'm going to do is I'll click here and then axis end, click it. Then you have to specify the default is arc, then there's center, then there's iso circle. So what we need is iso circle. You can either click this or equivalently press I and enter. So specify center of the iso circle. I'm going to make sure we specify by midpoint, and yeah, we basically need midpoint because we need to be in the middle of this. So I'm going to specify that midpoint and then track the midpoint from this corner. Do not click, you are just tracking and you are making use of those angles. Make sure one angle is 270, the other one is 330. Okay, so I have 330 from the left and 270 the one that comes from the top. So as soon as you see that, you can click and you get your center. So this circle is facing this direction, but like I said, changing the iso plane, you could press F5, then the circle is, you are assuming you're drawing the circle on top, then press F5 again. It's like assuming you're drawing the circle on the, you know, this right face of the object. Okay, but in our case we are doing it on the left face of the object. So press F5 again to switch back to that. So that circle is supposed to have a radius of 20. So just type, actually let's specify by diameter, which is 40. So D, and specify diameter, it's 40, and we are done. That is our circle. Yes, okay, so now we are only left with a few things to do. See, this is a circular hole and we need to finish and show that the hole continues to the back. So what I'm going to do is simply copy and paste this circle somewhere. I'm going to just displace it behind. So copy, and I'm going to copy the center, then along, it should be along 30 degrees. So along 30 degrees, I'm going to displace that circle by an amount which is 12.5. okay, because that is how far the hole goes through this part, which is the same as this part. So an amount 12.5. So I'll displace it along. Look for 30 degrees before you type 12.5. okay, so you can hit escape, and now we can join lines via we need to activate quadrant. Look for quadrant, and yeah, so that point and that point needs to be joined. Although they are not important, I'm just showing you what needs to be done. That point and that point. So that is our circular hole, but we are not going to need them. Okay, it should be the quadrant of the circle there. Okay, that is how the hole is supposed to be, but we are not required to do hidden details. So I'm going to trim. I simply trim that point, and we can just delete the other lines. Okay, and delete that part, and delete this. It's not required. So finally I'll convert this to the hidden details. Sorry, the outline, not hidden detail, outline. Then make sure show or hide line weight is activated, and yeah, this is our drawing. Okay, so yeah, in the next video we are going to continue with a different example. Okay.